Yeah, you can. Okay, look. You are given this equation. They tell you that the roots, there are two of them. One is twice the other. Normally, we write alpha and beta. But in this case, I have two unknowns, alpha and beta, right? Well, I am not using all the information that is given to me. And they told us that one root is twice the other. So why write it in beta where you know that beta is going to be 2 alpha, right? So in this way, I am reducing it to just one unknown. If I know alpha, I know the other roots, which is simply 2 times. Okay, from here, standard sum of roots equals to negative, and I have the coefficient of x, which is negative 2k plus 4 divided by 1. This gives me 2k minus 4. How much is this supposed to be equal to? Sum of roots. What is the sum of my roots? Plus, what's the sum of the roots? Alpha plus beta? It's simply 3 alpha. This is my first equation. Can you form your second equation? Yeah, I'm sure you can. Product of roots equals to k squared plus 3k plus 2 divided by 1. And how much is this supposed to be equal to? 2 alpha squared. Equation number 2. Look carefully. Isn't this simply simultaneous equation? Can do it, right? And that's our very first topic of AMAX. Any other questions? Okay. Now next, I want to talk about what I uploaded yesterday. In particular, question practice now 8. Please flip to practice now 8, that is on page 56. All these were already uploaded. I just want to spend some time to talk about it with you. This implies that we need to show that the discriminant is greater than or equal to 0. Why greater than or equal to 0? Greater than or equal to 0 is simply a combination of the discriminant equals to 0 and the discriminant is greater than 0. It's a combination, right? When the discriminant is equal to 0, I've got 2 repeated real roots. When the discriminant is greater than 0, I've got 2 distinct real roots. So these are the 2 cases where I have real roots. It's just a matter of whether they are repeated or not. Okay, so when they say show that the equation has real roots for all values of p, they are telling you to show that the discriminant is greater than or equal to 0. This is your goal. Okay so far? Now, we find the discriminant. Coefficient of x squared minus 4 times or coefficient of coefficient of x squared times the constant. So writing everything down, I have 8. The discriminant is equal to p squared minus 12p plus 36. We are supposed to show that this is greater than or equal to 0. Now in this form, I can't prove that it is greater than or equal to 0. Okay? Because what it means is that for whatever value of p I substitute in, any value of p, it is supposed to be greater than or equal to 0. You can try values of p, substitute it yourself, and convince yourself that, yeah, it is minimum 0. But why is that so? You need to explain. You can't be trying all the numbers in the world. So how do we explain it? How do we prove it? We recognize that, hey, actually this can be factorized. And I factorized it into p minus 6 squared. Can tell? P minus 6 squared? Yeah, okay. Then the question is p minus 6 squared greater than or equal to 0? By now, you should be very sure to say that, hey, yeah, this is greater than or equal to 0. Why? Because this part over here is a perfect square. It is something squared. When you square something, what is the minimum value? What is the minimum result that you can have? Not 1, 0. The minimum is 0 because positive times positive is positive. Negative times negative is positive. You see, the answers are always positive. But that is not the minimum. What is the minimum? 0. When do we get 0? 0 times 0. Okay? So yes, this is a perfect square. So the smallest possible value is actually 0. So actually we can conclude that the discriminant is greater than or equal to 0. Do we need to write all this down? No need. From here you just write greater than or equal to 0. You get it already. Okay? So the last part, the equation has real roots for all real values of p, shown. That's our final step. Okay? Any questions? Yes? Yes, there is another possibility that the discriminant could be greater than or equal to 0 when it is not a perfect square. Let me give you an example. Okay, let's try this. P square plus 1. Is this greater than or equal to 0? Is this greater than or equal to 0? Can I write it like this? What is a better way to write this? Okay, I give you an option. Greater than or equal to? Greater than. Why? Because you plus 1. This one over here, p square is greater than or equal to 0, right? So p square plus 1 must be greater than or equal to 1. So in other words, for the purpose of talking about discriminant, we are only interested in comparing it with 0. Whether it is greater than 0, equal to 0, or less than 0. So in this case, I will say that it is greater than 0. So yes, it is possible for a discriminant that looks like this, which is not a perfect square, and yet we can still conclude it is more than 0. Okay, what about something like this? P plus 1. Is this greater than 0? Okay, you fill in the blanks over here. Is it greater than 0? Greater than or equal to? What do you think? Can we tell? We cannot tell, right? Because I didn't tell you the conditions for P. But if I tell you that, in the question, P is greater than -1. So what now? If P is greater than -1, what are you going to put inside this blank over here? Greater than. So it depends on what the question says and what you can do with all the clues given to you. Okay? So that's all for chapter 2.2, the nature of the roots. The next part, chapter 2.3. I'm going to spend less than 5 minutes on this because it is actually a recap of what has been covered in EMATS. So here we have the minimum, maximum points of quadratic functions. So for fx equals to ax squared plus bx plus c, where in EMATS we say that y equals to ax squared plus bx plus c, we are going to have a graph. What is the shape of the graph? Parabola. Either it opens upwards or it opens downwards, right? How do we decide how it opens? It depends on the value of a, the coefficient of f of x squared. If it opens upwards, what can you tell me about a? Greater than or less than? Greater than 0. If in this case, yeah, it's less than 0. Okay? So it's the same over here. We are simply replacing y with fx because that's what we are comfortable with in AMATS, right? It's just a function. So here we will still get parabola opening upwards, parabola opening downwards depending on the sign, the value of a. And we have learned how to complete the square. You learned how to sketch the graphs already. But I want to draw your attention to page 59. Look at the top, completing the square, where a is not equals to 1. Remember what I told you about EMATS? What is the coefficient of x squared in EMATS?
1.
It is always 1. In AMATS, it is not always 1. So how do we handle it? What did I tell you to do? Factorize, yes, and that is exactly what work example 10 is telling us to do. Okay, so let us do one. I will do one with you now. Practice now 10, part A. We've got 3x squared minus 6x minus 3. Did they say that this is equal to 0? No, they didn't. What do they want you to do? Yeah, basically they want it to be in a completed square form. Okay? So, our first step, factorize the coefficient of x squared out. we get a 3 over here. Very conveniently, we get x squared minus 2x minus 1. Okay, they are equal. Now, all we need to do is to complete the square for whatever is inside this bracket, which all of you should be pros at it already. You should be really good at it. So I'll open a big bracket, and whatever is inside, I will complete the square. X squared minus 2x plus negative 2 over 2 square minus negative 2 over 2 square minus 1. These highlighted parts are exactly the same in value. All I'm doing is completing the square. So next step, again 3 with my bracket. Now the first 3 terms, combine it to become x minus 1 square. So there should be square brackets. And I've got minus 1 minus 1. So this gives me 3 times of x minus 1 square. Write it in the form that they want you to have it, minus 6. Understand? It is equivalent to 3x minus 1 square minus 6. Do you think this parabola has a minimum or maximum value? Minimum or maximum? Minimum. How do you decide? The coefficient of x squared is positive. So I'm expecting a parabola looking like this, right? If I write down that fx equals to 3x squared minus 6x minus 3. Okay, now recap. Your EMAS test is this Friday. By the way, I don't have time to do any revision with you. Minimum value. Because in this case, I've got a parabola opening upwards. It has a minimum value. When does the minimum value happen? It happens at the line of symmetry. Okay. When do we get the line of symmetry? When do we get a line of symmetry? Not the x-intercept. Yeah, it is at a turning point, but what is the equation of this red line? x1 plus x2 divided by 2. Yeah, you can do that if you know the roots, but in this case, I don't have any roots. Y equals 0. Are you sure this is y equals 0? Factorize. Why do I want to factorize? I already have the completed square. Think. I need you to think in the following manner. I want the smallest value over here. What is the smallest value? When does the smallest value happen? When x equals to 1. When x equals to 1, I've got my fx to be equal to 3 times 0 squared. Is this a coincidence? No, I planned for it to be that way. And I get negative 6. This is the smallest value of fx. You can't get anything smaller. Do you see it? Because the smallest, if I want the smallest value, it means that my perfect square, this square term over here, I need it to be as small as possible. And what is the smallest possible value? 0. That's it. And it happens when x is equals to 1. The line of symmetry is x equals to 1. It is not 1. It is x equals to 1. Okay? With my line of symmetry, I now have to show my turning point. What is the x coordinate? Obviously 1. That's my x coordinate. What is the y coordinate? Sub in 1. So we know that it is negative 6. This, if I were to plot it, if I were to sketch it out, since this is the vertical line x equals to 1, where is my y-axis? Left or right of the red line? Where is my y-axis? Left. Yeah, it is on the left. Okay, something like this. This is going to be my y-axis. Where is my x-axis? Above or below the minimum point? Above. It has to be above. Something like this. Now, if I draw it like this, I have one negative root, one positive root, right? I also, in order to sketch a graph, I require the values of the roots. So you are supposed to fill in the value over here, you're supposed to fill in the value over here. Okay? Depending on the values of the roots, my x-axis could be over there. It could be over here as well. I do not know. Because if my x-axis is the green line, I have 2 positive roots. So depending on the values of the roots, you will have to decide where to put the x-axis. Whether it is so far up, such that you get 1 positive, 1 negative, or you put it further down, such that you get 2 positive. Okay? Questions? None. Okay. So here we have the minimum value, which is negative 6. And it happens when x equals to 1. Alright? Let us try one question. So practice now 10, part C. Let us take 5 minutes for this. Stop at 10:42. Okay, for those of you who are done, did you factorize out negative 2 and result in this? You should have, like I mentioned, lower side work, all must be able to do it. So now all we need to do is to complete the square inside, x squared minus 5 over 2x. Although it's a fraction, it is not a problem. Add the coefficient of x, and we divide it by 2, and I square it. Okay, so we don't like to write divide by 2 like this, we write multiply by half with a negative sign. Sorry, I forgot. Yes? Can fraction over fraction? Yeah, you can, but I don't really like it. Negative 5 over 2, then draw a bigger fraction over here like this. Okay? Try and avoid using this lah. Then we subtract away negative 5 over 4 square, because they are the same. And that's it. Negative 2. The first 3 terms gives us our completed square. X minus 5 over 4 square minus 25 over 16. Next step. Negative 2. X minus 5 over 4 square plus 25 over 8. Right? So when do we get a minimum or maximum point? What are we expecting to get? Minimum or maximum? Maximum, yeah, it is going to be a maximum point. When does this happen? Yes, when x equals to 5 over 4, we get fx. So earlier on I should have stated fx, let fx, okay? So fx will be 25 over 8. And this is the maximum possible value. 5 over 4 and 25 over 8. You can choose to substitute any other values of x inside. I guarantee you the answer will be less than 25 over 8. Guaranteed. Because that's how the parabola works. Inequalities, right, such as x plus 8 greater than 0. Can you solve for x? X greater than negative 8. Did we come? Okay, so yeah, this is correct. What do we do on both sides? We subtracted 8 on both sides. Does the sign change? Okay, it doesn't change. What about something like this? 8 plus x less than 2x. What do we do over here? What do we do? Minus what? Minus x on both sides, okay? So I get 8 less than x. Then what happens? So x is greater than 8, right? Okay, it is? Okay. What about negative 3x greater or than or equal to 12? What do we do? What do we do on both sides? Divide by 3, okay? So I get negative x greater than or equal to 4. Then? Times negative 1 on both sides. So I get x with a negative 4. What is the sign? Less than or equal to? Are you all familiar with this? Need me to explain why? No? Knowing how to do it and being able to explain are two different things. So you all say don't need me to explain, huh? So no or don't know? Okay, give you an example. 1 is less than 5. Agree? Okay, change color. 1 is less than 5. All agree, huh? What if I multiply by negative 1 to both sides? I will get negative 1 and negative 5, right? What goes in the box? You use your common sense to tell me. Less than or greater than? You change the sign? Okay, let's try it the other way around. What if I have 10 is greater than negative 5? Negative 2 lah. 10 is greater than negative 2, right? I'm going to multiply by negative 1 to both sides. The sign, I don't know what happens yet, but this will be negative 10 and this will be 2. Use your common sense, tell me what's inside the box. Less than? Are you convinced already? Simple to explain, right? So don't just go around memorizing things when you don't know what you are doing. Okay, so now let's move on to, all these were linear. Look, the value, the coefficient, the power of x is simply 1. All are linear. But now we are going to get quadratic. Okay, so consider what happens if I have 2x squared minus 3x plus 1 is less than or equal to 0. What am I trying to do over here? If I ask you to solve this inequality, I want you to be able to tell me, for this to be true, therefore, after all the working, therefore x must be greater than something, or maybe it is x less than something, or maybe the answer will be x between something. Such that when I select these values of x, I put it inside, the left hand side will indeed be less than or equal to 0. That is the idea of solving inequalities. Correct? So then what is the missing steps over here? Well, the first thing that we can do is to factorize. For quadratic inequalities, I want you to factorize. This is quadratic, power, the degree is 2. Let's try factorizing this. Some of you are taking out your calculators already. If you know how to use your calculator to have it factorized, go ahead. But please do not make any mistakes. Because this is one case that traps can be set for you if you are using your calculator to factorize. Okay, so let us factorize this. What do we get? 2x minus 1 and x minus 1, is it? Less than or equal to 0? Let me do a quick check. Negative 2x. Okay, yeah, this is correct. Now what do we do over here? I want you to consider this portion. Do you know what to do if I change the question from inequality, I change it to become equal to 0? Do you know what to do? Yes. What do we do? 2x minus 1. Then we will say, 2x minus 1 equals 0, therefore x equals to half. Or x minus 1 equals to 0, therefore x equals to 1, right? Yes. If I want a sketch of the graph, what will it look like? Parabola opening up or down? Opening up. Does it intersect my x-axis? Yes. At which point? 2 points. Which 2 points? Half and 1. Right? This is if we are solving an equation where it is equal to 0. Okay? Now, this is my graph of let fx. So I'll use this to explain. So this is fx equals to 2x squared minus 3x plus 1. Right? Or we can simply call it y. Let y equals to that. Okay, the graph so far? What happens if I have an x value over here? What's between half and 1? Give me a random value between half and 1. 3/4. Okay, let's try 3/4, which is somewhere here. Can you substitute the value of 3/4, the x value 3/4 inside here, and tell me what is the value of fx? Quickly. Substitute 3/4 inside. Tell me what you get. Y is equals to negative, so this is 3 over 4, common, negative, how much? 1 over 8. What is the sign of the y coordinate? Sign being positive or negative or 0. What is the sign of the y coordinate? What do you see? Do you say negative 1 over 8? Okay, yeah, the sign is negative, right? Is that a surprise? Are you surprised to see that the sign of y when x is equal to 3 over 4 is negative? Are you surprised? Why not? Because this is my x-axis, right? Anything below here is less than 0, isn't it? Yes. Does that make sense to you? Yes. How about let's try one more value. Try something else between half and 1, but don't use 3 over 4. Try something else. You tell me what's the sign of y. Okay, try any value you like. Give you 1 minute. Please go and test it out yourself. It's the sign. Positive. You can in your groups, try any value less than half. Negative number, 0, positive number less than half, anything you like. I guarantee you the answer will be positive based on the shape of the graph. Does that make sense to you? Oh, what about this side then? Also positive, right? Okay, now let's go back to the question. So originally they said that this is less than 0, right? And I've got my graph over here that was drawn when I let fx be equal to 0. I let this be equal to 0, then I drew this graph, right? With the roots of half and 1. Now they tell us, hey, the green color part is less than or equal to 0. Which part is less than or equal to 0? The graph over here can be divided into 3 regions. What are the 3 regions? They are over here, the yellow part, this is the first region. Second region, I've got a region over here, and a last region. Can you see that? For different regions, I have different ranges of x. Tell me, how do you describe this yellow portion? X is smaller than half. Excellent. What about the green region? How do you describe it? Yeah, between half and 1, right? What about the purple color part? X is greater than 1. Now, I'm going to tell you what happens. When x is smaller than half, my y values, my fx values are positive. When x is between half and 1, my answer is going to be negative, meaning less than 0. When x is greater than 1, my answers will be positive. Now back to the question. They want it to be less than or equal to 0. I simplify the question a little bit first. Let's say it is less than 0. I want it to be less than 0. Which region? What is my value of x now? What is my range of x? If I want it to be less than 0, between half and 1, can I include half? Why cannot include half? What happens when x equals to half? Y equals to 0. What happens when x equals to 1? Y equals to 0 as shown on this x-axis, right? This is the line of y equals to 0. Okay? So I want this green portion, that my answer will be x between half and 1. But today the question is less than or equal to 0. So what's your answer now? Okay, so again, tell me the region. Is it the yellow, green or purple part region? Green. Does it include half and 1? Yes. Yes. So my answer is x greater than half, less than 1 or equal to. Okay? Any questions? And then you get to substitute any value of x you like to test out your answer, whether it is right or wrong. So what are the steps you want to start this question? Yes, so I've just given you the introduction. Now I'll tell you step by step how we should do it. By the way, I've got one more point to say. Now I want you to consider from another point of view. And I'm going to simplify this to be equal to 0. Less than 0. Okay, removing all these things. Class, something times something less than 0. What does that tell you? One of them is negative. Hey, listen carefully again. Something multiplied by something, answer less than 0. Meaning, something times something is negative. So what can you infer? What can you conclude about this? One is positive, other is negative, right? Can they both be negative at the same time? Can they both be positive at the same time? Cannot. So this is what it means. Well, you can use this to work out your answer, You can say if 2x minus 1 greater than 0 and x minus 1 less than 0, then you work out what is your x with an inequality, then you can answer. But you have another case, if 2x minus 1 greater than 0 and x minus 1 greater, this one, less than 0, then this one greater than 0, then you get another answer, x with an inequality, and then you need to combine them. then you get a final answer, x is either greater than or less than or whatever it is. That is troublesome. Using the graph is easier. But I just want you to note that this is what it means. When I say something like something less than 0, one of it is positive, one is negative. Okay? What if I say that this is greater than 0? What are the possible cases? Both are negative and both are positive. So we always have two cases, okay? Regardless, I recommend this method. And this is the only method that is taught to you. Okay? So use this, it will help you a lot. It consolidates, it combines all those thought processes. Two positive, two negative. One positive, one negative. It combines them very conveniently into this graph. Is it must draw a graph? Yes. Because it helps you. Okay, so let us take a look at examples. Practice now 13. Solve 4x minus 5 times 3x plus 1 greater than 0. I will take you through this question. You follow exactly what I write. Okay? Because I get very upset if you write things that do not make sense to the marker, but you think you know what you're doing and you get a correct answer. It's horrible to get a correct answer, but your presentation is wrong. Then I won't give you the mark. So watch carefully how I write it. Okay, solve quadratic. It is made out of two factors multiplied to each other. It is greater than 0. So this is what I write. When 4x minus 5, 3x plus 1 equals to 0. Keyword, when. Did the question say that it is equal to 0? No, they didn't. But I choose to say when it is equal to 0. What happens? X equals to 5 over 4 and x equals to negative 1/3. Agree so far? Agree? What's the point of doing this? I want to be able to sketch the graph. Is it a parabola opening upwards or downwards? Upwards. X over here. What are the roots? Where does it intersect the x-axis? Yeah, negative 1/3 or, sorry, the other one is 5 over 4. Okay? Now, the question didn't say that it is equal to 0. I let it be equal to 0. I chose for it to be 0 so that I can get these two values. Okay? Know the difference between inequality and an equal sign over here. Now that I have my graph, this is my graph of y equals to 4x minus 5, 3x plus 1. The question didn't say that y is equal to it. That's why normally, right, when you're sketched like this, you don't need to write the equation. But if you want to write the equation, let y be equal to, this. Okay? So y is equals to a quadratic expression. What do they want it to be? Greater than or less than 0? Greater than or less than 0? Greater. Where is the part of the graph that is greater than 0? Above or below the x-axis? Above. Okay, above the x-axis means I've got this region over here. This region over here and this region over here. This corresponds to above, right? Can you all really see that? All these y values, they are greater than 0. Those at the bottom, these are all less than 0. All these y values are less than 0. Okay, and they correspond to the regions of the graph. I want it to be greater than 0 means I want the yellow color region. Therefore, what is the answer? Once I have my graph, I got my highlighted parts already. Your job is to describe the yellow highlighted parts. What is the answer? X is less than? Or? That's it. Do we reject? Is there a reason to reject? You cannot reject just because you don't like the number. Just because it looks like a negative number. Cannot. You must have a reason. No. Both of these, they work. can I have you in pairs? Just somebody choose a value of x that is less than -1/3, somebody choose a value of x that is greater than 5/4, substitute it back into the equation, into the expression. You tell me whether the value is greater than or less than 0. From here on, I need to sketch my graph, right? It is a parabola opening upwards. What is the axis over here? Is it still an x-axis? No, it's a k-axis. So I can simply write over here, this is -13/9. This over here will be 3. Okay? If you want, you can write when k minus 3, 9k plus 13 equal to 0, blah, blah, blah. Like what I told you earlier on. If you want to remove it, fine. It's okay. Because as long as you know the thought processes behind it, I'm okay with it. So based on this inequality, I know that it is going to intersect at -13/9 as well as 3. So this is the graph I get. Since I want it to be greater than or equal to 0, I'm referring to this region. Meaning k is less than or equal to -13/9 or k greater than or equal to 3. This is my answer. This is a popular type of question that we will set for your exams and your tests, because we combine a few topics together. What does this actually mean? When you choose a value of k, if it is less than or equal to -13/9, if you choose a value of k that is greater than or equal to 3, you substitute it back into the equation. You have x squared plus something plus 10 equals to x minus something but x, right? There you have another equation. That equation has roots. It has solutions. If you chose k values in these two ranges, you will end up with either two different roots, two different value of x, or one same value of x repeated. Now if you choose any value of k inside here, if you choose any value of k between -13/9 and 3, you will get a you're not get 0. Your calculator will tell you math error, because you have no real roots. This is what this question means. Okay? Homework questions will be assigned on Google Classroom again. And I believe you can tell that